actually you have seen the tinning bar type. They'll keep the solution and they'll dip it so that the insulation comes out of it. And the major they have covered in this stripping chart, they are telling about this chemical insulation majorly in this stripping. Chemical, thermal and mechanical stripping types we are actually practicing. In that, if you come across this chemical insulation stripping agent, it is shell. Means when you are using this chemical insulation stripping type, then you have to always see that you are dipping a solid wire which has solid conductor, not the strands. Understood? People are able to follow. Like, for example, I'll give an example of coaxial cable. There, the conductor is solid, not the stranded wire. That you can't dip it in the chemical solution. So they are telling, be used only for solid wires. People are following? Any doubts? Insulation stripping agents, shell antandre chemical insulation stripping type na use ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ standard conductors ಗೆ ಇದನ್ನ use ಮಾಡಬಾರದು. You have to see that coaxial cables ನೋಡಿದಿರಲ್ಲ, so it will be very solid. So that type you have to follow. Being neutralized or removed prior to tinning or soldering. So ಇಲ್ಲಿ ಏನಂತಂದ್ರೆ ನೀವೇನಾದ್ರು chemical, if you want to use chemical stripping type, you have to do it. You have to strip it prior to tinning or soldering. As we discussed prior, sir discussed. He just told about the contamination. Am I right, sir? This will be covered here. Be neutralized or removed prior to tinning or soldering. Okay. Next.
Do you understand that what is neutralization of chemical? What is it?
Prior to tinning, you have to clean that.
Yeah, prior to the train, prior to the soldering or tinning operation, you have to remove the effect of the chemical. You have used a chemical to strip the wire, right? You have to remove the effect. The chemical will be sitting on the cable. That chemical has to be removed, cleaned thoroughly. Otherwise, the chemical is there on the wire still. What happens? It will further contaminate or deteriorate the wire, right? So it has to be removed prior to soldering or tinning. Continue.
The next point, that is equal to strand damage or end cuts. Can you people tell me where are the possibilities? What are the possibilities you make while stripping? You damage the conductors.
Selection of strippers.
Then
selection of settings.
Okay. There are many ways you can damage the strands. So, what are the acceptability criteria when you come across such like strand stripping the insulation? First is strand damage can lead to degraded performance. For example, like the mill area, you consider a 20 gauge wire. Okay, while stripping you cut some strands. What will happen? What are the effects of that damage? Can anyone tell?
Current carrying capacity will be reduced.
Yes, because the mill area is reduced. Okay, any conductor if you take, the current carrying capacity of the cable is always directly proportional to the mill area. Okay, if there is any damage to the conductor or the strands, then it will lead to degraded electrical performance. Okay, people are able to follow. You repeat. Want me to repeat? Artha aagta idya?
Shivraj? Artha aita? Can you repeat what she said?
Artha is.
Artha.
On point center ಕನ್ನಡದಲ್ಲಿ
ಹಾ
ಈಗ ನೀವು ವೈರ್ ತಗೋತೀರಾ, ಸ್ಟ್ರಿಪ್ ಮಾಡ್ತೀರಾ ಆಯ್ತಾ, ಆಗ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ವೈರ್ ಇಲ್ಲ ಕಂಡಕ್ಟರ್ ಕೋಯಾಕ್ಸಿಯಲ್ ಕೇಬಲ್ ಸ್ಟ್ರಿಪ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಅಥವಾ ಸ್ಟ್ಯಾಂಡ್ಸ್ನ ಇನ್ಸುಲೇಷನ್ ರಿಮೂವ್ ಮಾಡ್ತೀರಾ, ಆವಾಗ ಕಂಡಕ್ಟರ್ನ ಡ್ಯಾಮೇಜ್ ಮಾಡ್ತೀರಾ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ದೇರ್ ಆರ್ ಒಂದು 23 ಸ್ಟ್ಯಾಂಡ್ಸ್ ಇರುತ್ತೆ ಅನ್ಕೊಳ್ಳಿ ಅಥವಾ 25 ಸ್ಟ್ಯಾಂಡ್ಸ್, ಅದರಲ್ಲಿ ನೀವು 5 6 ರಿಮೂವ್ ಮಾಡಿಬಿಡ್ತೀರಾ. ಸೊ ಎಷ್ಟಾಯಿತು? 23ರಲ್ಲಿ 5 ಕಳೆದ್ರೆ 18. ಈಗ ಅದ್ರದ್ದು ವೈರ್ ಅದೇ ತರ ಪರ್ಫಾರ್ಮ್ ಮಾಡಕ್ ಸಾಧ್ಯನಾ ಅಥವಾ ಇಲ್ವಾ? ಯಾಕೆ ಯಾಕೆ ನೀವೇ ಹೇಳ್ಬೇಕು. ಸೊ ಕರೆಂಟ್ ಕೆಪಾಸಿಟಿ ಅಂತ ಏನ್ ಹೇಳ್ತಾರೆ, ಆಂಪಾಸಿಟಿ ಅಂತ ಹೇಳ್ತಾರೆ ಅದನ್ನ ಟೆಕ್ನಿಕಲ್ ಟರ್ಮ್, ಅದು ಕಡಿಮೆ ಆಗುತ್ತೆ ಆಯ್ತಾ.
And then today we have seen trim termination and insulation displacement terminations, and then we have covered in the morning session we have covered about solar terminations. So before going to the connectorization, can anyone define what is a connector?
It's a component which is used to connect cable with the mechanical assemblies.
So any other definitions?
Bunch of wires all together it's connecting.
Okay. So basically, you can define a connector as a device which is used to physically and electrically join two or more connectors. If you say connector, we have different pin alignment. Like we have 9-pin connector, 25-pin connector, 50, 100, and maximum 128-pin connector. Right? So we can also define as a different connector as a connector is a device which is used for mechanically to connect and disconnect the termination point. Two parts, because we have the cable plug part, we have the panel mount connector. When two are mated together, then we can have a physical electrical connections. So what do you mean by connectorization? So we define connector. So how do you define connectorization?
The total assembly.
The process of terminating the conductors to the connector we can call as a connectorization. So just now I had seen the video and they are defined different types of connectors. I request everyone to just give one example for each connector. I'll start with Shyam Matthew. Give some examples for connector.
Circular connector. That you want example.
Okay, one example. Circular connector.
Diesel.
Rectangular. Okay. Rectangular or some other example. Coaxial.
IDC.
Okay, IDC is an example for rectangular connector. Okay.
RJ45 connectors.
RJ45, Ethernet connector. Okay.
Torque fixing connector. I don't know the exact name. Some of the connectors we are inserting ferrule and fixing the torque. That also we call connectorization connector.
I don't think there is any connector which will apply torque. Okay. Normally torque is applied when we are interconnecting two assemblies. Maybe the connector and the back shell. Okay. Maybe the back shell to the adapter. So when we are using one or two devices.
Some of the finished connectors is there.
Okay.
This for connectorization process is there.
Okay.
Number of connections is pointed in ferrule.
Okay.
Is almost 25, 64.
Okay, that will call it as a splicing.
It's not splicing. It is for cabinet assemblies.
Okay.
Using in cabinet assemblies.
Okay.
That also will call connector.
Maybe I was not aware. Maybe I will take help of not.
In IPC also is not there.
Maybe a special
Ethernet, Jamnet connect.
We already covered RJ, but we have covered already.
D3
This type of circular connector.
IDC connectors.
This is a type of rectangular connector. Some examples. Some more?
D3
Indirect connector.
Indirect is the manufacturer who will make like zip connectors and wrapping. It is a part of rectangular connector, Indirect connectors. So we have some more connectors like zip connectors, like zero initiation force. Just make to the mating end, rotate it so that it will get locked to the mating part. And we have mass interconnect connectors. Okay, where we can interconnect around 500 to 1000 connections at a time. It may be the power signals. Okay, it may be the power. It may be the signals. It may be the RF signals. Everything will be interconnected in only one part. So it basically will call as mass interconnected connector. So these are some of the examples on the connector types. Okay. So in this particular section, in module 4, which cover the section 9, so we will be covering Yeah. So we'll be dealing with hardware mounting, like installation of jog post and jog screw, and then followed with the strain relief. In strain relief, basically we use the strain relief for avoiding stress on the wires. Followed with sleeving and boots, which will be mounted over the rafters. Connector damage. Connector damage may be with the physical connector, and each connector will have two phases. One is the hard phase, other part is the soft phase. The portion where you are inserting the wires is called as soft phase. The other part where it is going to mate with the mating connector, that part is called as hard phase. And then installation of contacts and seal plugs. So if you have a 50-pin connector, maybe actual termination will be using 30 pins. So remaining 20 pins has to be installed with the seal plugs, dummy contacts. Maybe it depends upon the customer. Okay. Some customer, he may ask you to install the dummy contacts as well as seal plugs. Some of the customers, they may ask you to just install the seal plugs. So what is the purpose of using the seal plugs?
In order
Foreign objects
to prevent FOD materials entering into the plant.
Okay. And second reason is just during the vibrations. Okay. We should install the seal plugs. And then over molding. And okay. So I'll be covering only this 5 sections. Okay. Before going to the connectorization. Okay. We have seen the circular connectors. For any connectorization, the process involved is wire preparation, termination, and then followed with the insertion of the contacts into the circular connector. Okay. Just I'll take example of circular connector. In circular connector we have sockets, flex, and we have solder type and crimp type. So when you are inserting, we should follow some technique. If the insert arrangement is circular, if this is a circular connector, if the pin starts A, okay, maybe it is Z. So make sure the insert arrangement for this type of connector should be, the first wire should be inserted at the starting point A, which is the center of the connector, and follow the clockwise. Okay. If the pin arrangement is starting from 1 to 10, followed by 91 to 100. In this case, we should start the insertion from below to top. Okay, this will call this as wireless method. So we are inserting the contact starting from bottom to the top. Okay, and the process of inserting the contacts into the connector is called as populating the connector. So what will happen if you insert from top? This is a standard method. It is defined as standard that if you are going the first pin in the center, we need to follow the clockwise. If it is leftmost to rightmost, then we are following from bottom to top. If I follow the inserting the contacts from the top, what will happen? Why we should not use it?
When the topmost get populated, it is difficult to insert the wire from the top.
So as you rightly said, if I insert here, the wire will be hanging like these things. So it will be not feasible, or else it will become difficult for inserting the next contact. Clear? And for this inserting the contacts, we should use insertion and extraction tools, which may be the plastic, or else which may be the metal. Normally we will recommend metal because there is a chance of plastic material to break when we are inserting the contact into the connector. Once you insert the contacts, okay, the technique behind this is push, hear the click sound and pull it. We are pushing the contact, we should hear the click sound and then pull it. Make sure that the contact which you are inserted is properly inserted. And then we have the other additional method where we are going to use retention tools. As the name tells, it verifies the insert contact has been retained in the position or not. So we need to apply some pressure and make sure the contact which is inserted is retaining in this position. Just I thought to give some brief introduction on this connectorization. Do you have any doubts? Fine. So section 9.1.1. So it deals with hardware mounting jack post height. So this section covers the height relationship at the face of the jack post to the associate connector face. This is critical to obtain maximum connector pin contact. So normally where you will see this jack post? In the cable plate part or in the panel part? If you see the picture, normally this arrangement will be there on the panel side or else on the equipment side. So this is called as jack post. See, the hardware stack up for mounted connector may be varied in order to locate the face of the jack post flush, and it can be plus or minus 0.5 mm. This jack post face from the connector face, it can vary 0.75 mm. So as per the acceptability class 1, 2 and 3, jack post face is flush plus or minus 0.5 mm with the face of the connector. Height is opened by adding or removing washers. So if you want to attain 0.5 mm, so we may have the spring washers, we have the plain washers. To attain that height, we can install or else we can remove the washers accordingly. So what is the difference between class 1, 2, 3? Face of the jack post is more than plus or minus 0.5 mm. If it is more than 0.5 mm, what will happen?
Connectorization will not happen.
It won't make
Properly. Some of the contacts may get contact, some of will not get contact. So not get proper connectorization. What will happen if it is less?
We can't able to tighten the screws.
So if it is less, we can't properly mate with the jack post. The screw cannot mate with the jack post. During the vibrations, okay, it may come out. So basically in the military and defense, we prefer only circular connectors because it's compact in nature, lightweight. Second one is it will withstand the vibrations, and third one is it will withstand the severe environmental conditions.
Good afternoon. Now we are going to see marking and labeling. What do you mean by marking and labeling?
Identification.
How many kind of marking you have seen?
Marking tubes, sleeves, labeling type.
Okay.
And then wrapping.
Some of the hard stamp also is there, inkjet printing.
Direct and indirect.
Direct and indirect. So marking we can do cable marking as well as wire bundle marking, sleeve marking, wire marking and sleeve marking. Actually, if you see, I think everybody from aerospace only, right? Huh? So you have seen the marking in the cables. Can you tell any one number? Can you remember any one number?
W320.
Well, actually, it is having some meaning. So what number we are printing that, we have some meaning. I explain that. So whatever I have boxed it, that is not, it is required for all the wire bundle. Whatever I did in box, that is important to all the wire bundles. First we have seen the unit number. This is called unit number. If you see the aircraft, you have multiple units like ADF, automatic direction finder. You have 2 units. One is for if you see all the aircraft, some primary units it will be 2. If one is going bad, other one they will use, like the weather radar, then ADF and all we have 2. That time what we will use, if one wire ADF it is having, they will mention 1S like that. If it is 2S they will mention. For that purpose they will use this digit. This is S. This letter function like function letter. By seeing this letter, we will come to know what purpose this is. If it is S, that is for radar systems. Like if it is B, that is for photographics. If it is C, control surface. If it is D, that is instrumentation. If it is E, that is engine systems. Like that. By seeing this letter, we will come to know. Then this is the sequence number. If you have any one system, like ADF, this control system, this receiver, then this is antenna. These are wiring. If you see this number, they will start with 001, 002, 003, 004 like that. This is a sequence number. This letter represents a segment letter. This is called segment letter. If some wire bundle is going through some bulkhead connector, for example, this will be in the cockpit, this will be in the avionics bay, this antenna will be in the surface, that frame of the aircraft. So in between that bulkhead connector, bulkhead cabinet will be there. This meaning of this one, it should not be any leakage of this air. This is a compressed area, so there should not be any leakage. So that time they won't directly thrown through the cabinet and they won't take the cables. Usually they will use the connector, that is called Vulcan connectors. In these places, if this cable is running 005, they will put this side 005A, this side 005B, 006A, 006B, like that. For this purpose, we are using this. This is nothing but a wire gauge. Which gauge you are using? If it is 22, they will use 22. Same wire bundle, if it is 26, they will put 26 like that. Then this letter is for kind of, if it is N, that is represent, this is for ground. If it is A, B, C, if it is 3, it is there means it is represented, this is one power cable, the 3-phase power cable. This is one power cable, this one, this one. This represents the 3-phase power cable. Then this is M. M means modification. It is for actually when if I aircraft the aircraft as a OEM, I won't mention this one. If I fully completed the aircraft, I sell to some other person like HAL, I sell the aircraft. If they want to add some more equipment, that time they will mention this one. It means that it is not original that aircraft manufacturing, they have modified. This represents like that. If it is a EMI cable, it will come for, they will mention that this is the EMI cable. This for wire identification. This is what they will, actually they will conduct for globally. But you see any aircraft, usually they will follow like this only. Then we'll go with wire identification. It is having two types. One is direct, another one is indirect. What is direct and what is indirect?
So direct means is directly applied to wire.
Yes.
Indirect means is the wrapping or the sleeving.
Yes, correct. If it is direct, in direct we have two types. One is laser wire mark. Another one is art stamping, also we can do it. In indirect, usually if you see this wire may be conducting that wire IDs in laser print also, then also they will use the sleeves. What is the purpose that?
Manufacturing.
Yeah, that is for a manufacturing head. If you see in the some supplier they will take every 3 inches, some supplier they will take every 6 inches, 15 inches like that. If you see the termination end, some places we can't able to see the number. Either we have to rotate the cable, like we have to see. So based on that, what they will tell, we have to use the indirect sleeving on both termination end. So in that purpose, we will use the sleevings. In that sleeving also we have art stamping as well as laser print. This is understood that what I explained. Okay. Now we can go with the IPC. This module speak about marking and labeling of the wire bundles. This labeling for wire bundle securing, shielded or harness, production covering and finished good also we have to use that. marking and sleeving. This chapter is covering of marking, labeling, securing and electrical shielding and protective covering, finished with installation. But now we are going to see only marking and labeling. But this one is different. Next slide.
No, here. See the same thing. This is the slide. And this is as per the book. So you can just concentrate on this here. Whenever there is a figure here, only then you have to follow this. The figure, if you are not there, then you can follow this.
This section is for marking and labeling. If marking is not required, if it is not required, the user is telling that it is not required, we don't want to follow. If they are not mentioned any method, we can follow with the IPC standard, whatever they are mentioned in this section. Regardless of marking method used, marking shell, defect for 1, 2, 3, containing of incorrect content. What you are going to type, if it is wrong, it is defect for all the classes. What will happen if it is wrong?
End user.
It may go with function. Yeah, if it is 001, instead of that you put 002, what will happen? They will crimp in the wrong contact, they will insert in wrong position. So it will end up with function defect. If it is illegible, what is legible? We should be able to read that. If it is big letters also, we have to able to read that. Letters ದೊಡ್ಡದಾಗಿದ್ರೂ ನಾವು ರೀಡ್ ಮಾಡಬೇಕು. In case ನೀವು ದೊಡ್ಡದಾಗಿ ಹಾಕ್ಬಿಟ್ಟು R ಇರೋದು ಹಿಂಗೆ ಇಲ್ದಿರ ಇದು ಕಟ್ ಆಗೋಗಿದ್ರೆ we can't able to this misleading that it will be look like P. They will read it as P. What will print it should be permanent. It should be long life. ನಾವು ಒಂದು ಪ್ರಿಂಟ್ ಮಾಡಿಬಿಟ್ಟು ಆಫ್ಟರ್ ಇನ್ಸ್ಟಾಲೇಷನ್ ಆದ್ಮೇಲೆ ಅದು ಫುಲ್ ರಬ್ ಆಗೋಗಿದ್ರೆ there is no use. So it should be long life. So ನಾವು ಮಾರ್ಕಿಂಗ್ ಆಗ್ತಾ ಇರೋದೇ we can able to easily identify. But ನೀವು ಮಾರ್ಕಿಂಗ್ ಮಾಡೋದೇ should not create some problem. That's what it is telling. If damage the product or impair the function it will make repair. It is not correct. It is defect for all the classes. So marking whatever is printed without magnification, we can able to see that. We should print like that. Now print ಮಾಡಿದ್ಮೇಲೆ ನಾವು ಒಂದು ಮ್ಯಾಗ್ನಿಫೈಯರ್ ಮಡಿಗೆ ನೋಡೋಂಗೆ ಇರ್ಬೋದು. So it should be ನೋಡಿದಾಗ ಗೊತ್ತಾಗಬೇಕು.